Yes, I think we are live at Space Challenge, and I'm so excited to welcome you in our second session. So today I have Jurry with me. He is the head of international sales, and also he is managing the project of Copernicus data space ecosystem together with European Space Agency. And today he will enlighten us about the Copernicus data space ecosystem. And before moving further with Jurry's session, I would like to remind you about the IoT Space Challenge and why we are hosting these learning sessions. So Europe IoT Space Challenge is the brand new program of hubraum, the tech incubator of Deutsche Telekom, together with the European Space Agency. And we are bringing the teams with expertise in IoT and Earth observation together and looking for use cases in these joint fields. So we encourage the companies to apply for if they're interested in B2B collaboration opportunities between these two technical domains. And we are looking for the companies with more mature stage. So you should ideally have your MVP tested in the real life setting. And this program has a lot to offer for the participants. So we are offering a prize pool of up to 60,000 euros to sponsor the creation of your use cases and POCs. We are providing IoT creators connectivity, Deutsche Telekom IoT connectivity, together with an expert support. And we are providing each team with an IoT prototyping platform for them to test out their use cases. We are providing access to European Earth observation data with European Space Agency expert support. We are giving an access to Copernicus data space ecosystem, where Jurry will explain in a minute, with credits and T-System expert support. You have the access to your hubraum campus spaces in Berlin and Krakow, so you can work and prototype from our offices. They have a lot to offer. Also, they offer the AWS credits, of course. We do offer potential co-investment by hubraum fund up to 1 million euros, and you also get the opportunity to join larger European Space Agency incubation programs. And as you might know from our social media, that our program already launched, and we are currently hosting the learning sessions. Today is our second session, and we're gonna have 2 more sessions that you will see the calendar. And the important point here is that the application deadline is March 31st. So if these 2 different domains are any appealing to you, you are very strongly encouraged to apply from the link that you can see on the bottom of your page. Just keep that in mind, that the deadline is the end of this month, and we are looking forward to your applications. And here is the calendar of the learning session. Last week we hosted Afzal, that he gave us an overview of cellular IoT using the IoT Creators platform. And today we have Jurry with us, that he will enlighten us again about the Copernicus data space ecosystem. And next week, Frank and Valentin from European Space Agency will bring these 2 topics together and give us an overview on use case and application of IoT and space, together with how satellite IoT is serving the Earth observation data. But before moving further, let's come back to today's topic. So I'm very glad to have Jurry with me, and just some practicalities about today's webinar, and then I will give the word over to you. Today's session will be 60 minutes, including Q&A, and your questions are always encouraged. Please ask them using the chat function on LinkedIn. As you see, they will be answered either throughout the webinar or at the end of the webinar. And this session is recorded and will be shared with the participants from the hubraum's LinkedIn page. And with that, I'm handing the word over to you, Jurry.
Yeah, thank you, Janset, for the nice introduction and this opportunity. Yeah, for me, it's quite exciting, of course, to be together with interested people and parties to look at IoT
Glad
and
to have you here.
Earth observation. So, yeah, my name is Jurry de la Mar, and I'm working since many years with Deutsche Telekom T-Systems, a large IT provider with services for government and enterprises. And one of my big tasks and programs is working with the European Commission and ESA on the Copernicus program, where we have just started a new contract to provide the Copernicus data to the worldwide community that is using it. And I will be speaking about the Copernicus data space ecosystem, as we call it. And I hope with that to give you a good understanding of Earth observation data, what it can mean today for different types of use cases. I have to say at the beginning, I'm not an IoT expert, but that you will have in the other sessions. So I may be also able to learn from you in this session with your questions of where those use cases that we already know from experience can benefit in future from also IoT technologies. So the Copernicus data space ecosystem, just a few words about the project that is run by T-Systems, but not alone. We are running this together with a number of partners. You see the logos here on the first screen. Cloudfero from Poland, which is a Polish IT company specialized in Earth observation that already run also a large data center with data providing the data for Earth observation. Synergize, a company from Slovenia that provides a number of the applications that we use. Vito from Belgium with also applications for special use, for example, in land monitoring. Acri from France, a company also specialized in certain tools for satellite data evaluation. DLR, the German Aerospace Center, that of course is one of the big space agencies in Europe that helps us with the scientific background. And REA, a group from Belgium that provides us with expertise also on the working with Earth observation data. So you can see it's also a project that we run with really a European team of different backgrounds, also SMEs are inside this group. So also this shows that Earth observation is really about bringing together large enterprises and expertise together with very dedicated expertise on Earth observation to make this possible, what we will be speaking about in this hour. So let me go to the first slide. Before I dive maybe into what we do, first some words about the Copernicus program, which is a program of the European Commission, and a program that started already back in the 90s under the name of GMES and was later rebranded to Copernicus, one of the famous scientists we have in Europe. And the Copernicus program is Europe's eye on Earth. Yeah, it really provides as the task to provide all Earth observation data that helps us look at our planet and its environment and understand it first of all, but also then of course to have the necessary information to take action. And I think all of you will know these actions are more and more important. If we only think about the first major action, monitoring the climate change, I think we all know how important that has become. And also things like extreme weather events. Also here we have seen recent examples in Europe of how that can impact not only the environment, but also really day-to-day life. And then tasks like land use, ocean states, air quality, and of course supporting things like border control and emergency response. That are all tasks that are part of the use of Copernicus data, and shows that the application of satellite data has become very, very broad, embedded in many, many different applications. And you can see that on the right side of the screen. I just used some examples from the Copernicus.eu webpage that is provided by the European Commission. On that page, they also publish already a number of use cases that have been established over the last years. I just show here some examples of that, from vegetation index monitoring to aquaculture to ship weather routing systems. So very diverse applications. And yeah, that shows why we have, since 2014, when these data, these satellite data that are being used became online for the first time and were free and open to use, that we have grown from 0 users in about 8 years' time to more than 650,000 users that are maybe not using that data every day, but are on the system active and will also be able, of course, to use that on demand when needed. And we know at least that several 100,000 are regularly using the data. And the data has become also extremely voluminous. We have, of course, now already like 8 or 9 years almost collected data from those satellites, and all of these are online available. And that means we have almost, already more than 60 million products, meaning satellite images of a certain type that are available to those users. And they are downloading it also, of course, every day to use it in different applications. And more, what we will see, directly using those images to derive information in a cloud environment. So that's a very large community. And that's maybe also one of the motivations, I would think, for now looking at areas like IoT to complement Earth observation. Because if we can do new things, it will be visible to a very large community right from day one. If we could complement applications with these type of technologies, there is an existing market outside with established applications that could benefit right away, and probably also will be able to, or prepared to pay for that. Because the data is free, that is of course a real incentive. Everything that you develop with the data might be then commercial, but the data itself stays free, and that is in contrast to some of the commercial satellite data that can be very expensive to obtain. Then let's look at the Copernicus data space and why it is called an ecosystem. Well, as you heard, the data is already collected over the last 8 to 9 years with several satellites. I will show that on one of the next pictures, by ESA, and the data is then distributed on behalf of the European Commission to the worldwide community. And that was done on different platforms until now. Last year, the Commission decided to really establish a new contract with one public service called the Copernicus Data Space, so that all the services that are available and all the data that can be accessed is going to be accessible from one web portal and from one, say, user identity that you then register yourself on that portal. And you can see that portal here in this image. We will go to the web page later to give you a quick view. And that is really a public service. We will come back to that, what that means. And that means we believe that even now, still more government entities, national entities, European institutions will then be able to use that data more effectively in their programs. We know the data is already being used in agriculture, in climate, in environmental projects, but we believe it can be used also in many other areas of government to help them take better decisions, as the same as in the national member states. And that, of course, also requires new research. So it's also important that the research communities have access, of course, to this broad data sets, and that they can help the governments to develop those new applications. And we all know that the environment is becoming such a priority that the European Commission has also started the Green Deal program that has identified a number of additional policies and programs that need to be implemented now in government, in industry, and also here we see new activity to make use and do analytics with the satellite data that's available. And that's not only government, of course, industry is also very interested, as you can see from agriculture. Today we are talking about precision farming, for example, also a topic I think interesting for IoT. Precision farming means that a farmer does not have to really analyze himself anymore how he can, say, increase or maximize the return of his land or his crop, but is being supported by information derived from satellite data, where to use the fertilizer the most, or where should water be applied or water saved. And that helps, of course, all the farmers also to be more effective and be more efficient. And then we have IoT as a new component. As I said, I'm not an IoT expert, but talking to some of the network we have in this area, and what you will see probably in the next sessions, in the next training sessions, where IoT, we believe, can make a difference are typical things like infrastructure monitoring, water management, and wildfires. Because what we see there is obviously that the satellite data often clearly shows where and solve a problem. But looking from 700 kilometers above the Earth, you cannot see everything down on the ground, and that is where, of course, IoT can come in to then do the more detailed or specific analytics that are used to really manage a situation on the ground itself. And hopefully the other specialists will give you better ideas and more clear directions in the next sessions. But I will show later in the presentation, when we will go to the web portal, I will show you some examples of what has already been done, both by governments and industry, and then you can see where maybe are the use cases for IoT in future. That all of this data and the services that we provide with this data space is also commercially available. You see here in the second web page picture, under the Creo Dias brand, we are also providing this as a commercial service to any startup, enterprise, also government, of course, entity that would like to use these services in a more, say, regular or more scalable way, and use the data every day to analyze certain situations. And that is done in a public cloud. So there, the services can be directly used on demand, pay-per-use basis. So also only when it's needed, the data is then processed. The public service itself is financed by the European Commission. And here the services and the data that you can obtain through the public service are free of charge for the user. Yeah, so I think also for this challenge, we cover 99% of what you will need to investigate maybe for a new idea. And through this page, you can try out what I will show you later, maybe exactly the things that you need for your business idea. But let's go a step further. Let's go into that public service more in detail. What does it mean? What can you expect when you will go later to the web portal that you will see? So first of all, we have shown you that by collecting all this data from different satellites, we are really having an incredible amount of data, and it is an incredible amount of data that goes back to 2014. Yeah? So you can really do analytics over the past period until 2014. Not for all the data, but I will show some more detail in the next slides. And we will continue with that. Yeah? That's also very important. The contract with the Commission is for the next 6 to 10 years. So that means if you would create a service based on this data, you will be able to at least run it for the next 10 years, I would say. And of course, your users will be happy to hear, of course, that there is this continuity option. So, and definitely after that, we also believe that the program will be even more extended than it is today. And also that the data will still be free and accessible by all the applications running on top of it, as there are already so many. If we go to the satellites themselves, what can you expect out of this data? And this data is very diverse because we also have different satellites that fly around the world since 2014, starting with the Sentinel-1 satellites that are usually polar orbiting satellites, which means they fly across the North and the South Pole all of the time. And then if you think that the Earth is turning every 24 hours, you will probably understand from a 3D geometry, it means that the satellite will scan the whole Earth basically, because they fly around the Earth in 90 minutes. And when they return to the same point, the Earth has already turned to the next, say, geometry. And that means with two polar orbiting satellites, you have the same picture of the same city or region like every 2 to 3 days in Europe. And that, of course, is a very high frequency that makes it interesting to really also look at changes that happen. And the radar satellites, the Sentinel-1 being a radar satellite, have the big benefit that you can use it day and night and under any weather condition. So they really do a 24/7 observing of the Earth's surface. The second satellite, which I will show later, the first example of pictures, are also these polar orbiting satellites, so the same frequency of data. They are multispectral, meaning they scan in different wavelengths, both in the visible and some of the non-visible spectrum. So these are I would say, the most common known satellite images, because that is what you usually see in a newspaper when a satellite image is used. You see like a picture, of course, a visible picture, and that is what the Sentinel-2 satellites do. But them having different wavelengths, using different wavelengths, means that you can look at different things at the same time in the same picture. So, and we will show examples of that, how that works. And then we have the Sentinel-3 satellites, also two satellites that circulate the Earth, a very different instrument that measures the sea surface topography, so waves, for example, but also the temperature of both sea and land. And then things like ocean color and land color that helps especially in applications for the environment and the climate monitoring. Probably you know the ocean is one of the biggest elements of our climate, and the changes here have a dramatic effect on what we will see in the next years. And then as the last satellite, we have Sentinel-5P, which is a precursor of the Sentinel-5 satellite that will come in the next year. And that monitors gases and aerosols in the air, in the atmosphere. So that helps us understand how air quality is developing and changing with the climate, and what is the impact on day-to-day life for citizens and of course for the vegetation. So you see very different and diverse data that is being collected, and all of this available in the data space. And normally that will be on a worldwide coverage for most of the data. If it's not explicitly excluded, of course, we don't provide pictures over the ocean. That would not make a lot of sense. That is done by the Sentinel-3 special sensors. The normal pictures are, of course, taken over land. How can you access that data? So as I said, there are two web portals, one being the public service that you can access, and you will see it later through this URL, dataspace.copernicus.eu. And all the data and the services you will be able to access there will be free of charge. So funded by the Commission. You can register yourself. You don't have to call anybody, get an intervention. Everything you will see is self-explanatory. You'll get direct access to all the documentation that might be needed, how to access the data, how to use the data also through APIs, so that you do not have to go through the web page itself, but can also program a certain workflow prototype to use a certain type of a certain selection of the satellite data. The same we have on the commercial side, on the commercial platform. Good, sorry for that. So the commercial portal of course, if you really want to implement a business case, a new service, that will be the place to go, where then you can select certain cloud services to analyze and process the data. We will show an example of a cloud system also in the slide shortly. And that is set up as a marketplace. So here we especially say motivate everyone with a good business idea to come here and use the data that's already there, complement it with other data like IoT derived data or data from IoT sensors, and then implement this. But you can also, of course, take the Copernicus data, download it, and use it in another system to do the same. That is, of course, for everybody free to decide. The marketplace, of course, will have the benefit that once you publish it there, the application will directly be seen by this huge global community that uses the Copernicus data also for other purposes. Okay, to be able to work with the data, and satellite data being, of course, complex, it's well known how to work with data, but maybe not for everyone that is not really a geo information expert. So what we have done is to complement the data with a number of tools and different standard interfaces that make it very easy to work with the data, almost on the level that you can virtually program a workflow and then get the results for your particular application. And that service is provided also on the public platform. So there are also ways to first of all run that as a prototype free of charge. That will become available in the second half of April. So I believe that will be in time for the challenge really to make use of it. And of course, if there would be then more extensive use needed than is available with the free service, then it can be also run as a commercial service for you. So well-known tools like Jupyter Lab will come with pre-configured scripts to really access the data in an easy way into a workflow or a program. If you want to process, of course, you also need a computer. A computer is, of course, best placed next to the data. And that's exactly what we do. We run a cloud, the data is in a cloud, and we also enable users to directly use cloud resources to process the data. So in that case, you have the full choice of how to process that data with what type of software. You can bring your own software, install it in the cloud. You can use tools that are already embedded into the cloud, like Kubernetes and Docker containers, or certain applications to evaluate the data. So that will be available also for you, and that will be part of the commercial service as well. And the functions that you can expect, for example, in the Open Telecom Cloud that we run and that supports this data space, range from computing to network to storage functions, the container orchestration, what I mentioned, but also you can really even build your own web service, of course, on top of it, and protect that with security functions, a web application, firewall, load balancing, and all these things are today embedded in the cloud functionalities. So that makes it very easy and very quickly to basically set up a small machine that may only cost a cup of coffee a day, and then of course use the data really to analyze it and to connect it maybe with an IoT application. So we have maybe now got a first understanding of the Copernicus data space, what it means. And here you see an image of the browser, which I will show directly after a video that we will share with you, so that you get also maybe a little bit different impression of what can be done with the Copernicus data. And after that, I will come back to you, and then we will step into the browser and show you some of the examples of how to work with the data. So, Jan said, if you can start the video, that would be very nice.
Vast amount of imagery is generated every day by the Copernicus satellites orbiting the Earth. There is a need for an infrastructure that holds a complete and up-to-date collection of data in one place. Introducing the Copernicus Data Space ecosystem, built around data, services, and applications. Hosting the largest archive of data from the Copernicus missions, this new distribution platform is evolving from Copernicus Open Access Hub and DIASes. It ensures continuity, improvements, and opens doors to all the data and infrastructure you need for your Earth observation applications. The Copernicus browser gives you access to data from the Sentinels and other Copernicus contributing missions, providing you with all the data you require for making informed decisions in the ever-changing world impacted by climate change. Be it mapping floods, monitoring land and sea, or detecting ships with Sentinel-1, or mapping changes to the vegetation and land cover with Sentinel-2. You can also detect forest fires and monitor land surface temperatures with Sentinel-3, and monitor the atmosphere with Sentinel-5P. In addition to the Sentinels, the system also contains data from the Copernicus contributing missions, providing additional information that can aid you while building your solution. The Copernicus Data Space ecosystem lets you search data from a particular day or within a time range, visualize in a web-based application, download the original data directly, or access large amount of data in the cloud with suitable formats via API, as well as create time lapses. Not just this, it is also possible to access several on-demand processors, easily scale up applications with easy access to cloud computing, enabling you to process data at scale, and trace where the data came from. The ecosystem is constantly evolving and more features and data are coming soon. All of this is available free of cost for use by individuals, researchers and companies funded by the European Union. Earth observation is entering a new era with instant access to enormous data volumes. Now it is your turn to utilize the platform and lead the way in making the planet a better place to live.
Yes, very nice. Thank you for playing that. So yeah, go back to the web application. You see here the browser. Can you confirm?
Yes, we can see the browser view.
Good. Okay. So this is the URL that we were speaking about, the entry to the public service of the Copernicus Data Space. And first showing you that there is, of course, a number of information provided here to make you understand the outlines of the Copernicus program. You also see here the video that we just showed. And important will be, I guess, if you want to try this, is the documentation, where we can go to short moment to show you the things like the data. Yeah, how is the data organized? Yeah, I was talking about this Sentinel-1 satellite. Yeah, what is the data containing? How can you access it? Yeah, so here are the different descriptions of the data and the APIs. So how can you access the catalog, and how can you search the catalog by using a program instead of the browser, as I will do it right away to make that simple. And along the way, of course, this is at the very early stage. We have just started this service 2 months ago. We have a major update then in April and in June. And then, of course, this resource documentation will also be extended to describe the new services that will come online, then step by step. But let's go back to the webpage. So if I would then like to access EO data, I will come to the browser. I've already opened it. And here you see basically a world map, and without knowing which satellite is where, what has been collected over the last days or the last years, I can simply, of course, enter a region of interest to first search there. And let's go to Krakow, because it's the hometown of Hubraum. And I know that in the recent days, there was actually a very nice picture of Krakow, because this is, if I say show the latest date, it of course already has like a cloud filter built in, because if I would have a satellite image only with clouds, that would not be helpful. I see that there is a very nice picture from 12th of January, where it's almost cloudless. Yeah, this is the Sentinel-2 sensor, yeah, the multispectral image. So we get here the full visibility of what is down on the ground. We understand almost what we see, yeah, the city and the surroundings with agriculture, an airport that you can easily recognize. And this already gives a lot of information. Yeah? So I see the surroundings of the city, I see the infrastructure, I can of course zoom in and see the details that are in the picture. I can zoom out again. It takes some time to refresh the screen because my internet connection is not that good today. Just a second. What is happening? Okay, good. Coming back. But that's only part of the truth, yeah? Part of what the sensor has seen because of these different wavelengths that we monitor the Earth. Yeah? So, for instance, if we would like to see something more relevant to agriculture, being the soil moisture, yeah, what is the level of moisture in the ground, important for a farmer. There are these built-in filters which we can directly click, and in this moment what we actually do is we calculate from the information that's embedded into the satellite image on the fly, pixel by pixel. We calculate what does it mean in terms of moisture. And if I show you that are of course algorithms that have been developed by science over the last years and tested with ground monitoring to really make sure that what you see here is as close to the truth as possible. And you can see here that this index, this moisture index, shows you very quickly and clearly what is, say, very good condition, yeah, the blue areas, and what is in very bad condition, the red areas. And that, of course, gives me now a totally different picture of what is there in the same area. Yeah? And of course, here again, we can zoom in. I can do that right away. But let me also show you another filter, how that works. So scene classification, important for governments to have a very quick view of what type of use of the land is where. Please forget the brown area that are cloud shadows, yeah, that is indicated here. But you can see here very clearly the difference between vegetated areas and non-vegetated areas, or water or topographic areas. So these are the tools that can be directly used to filter out that information that is really relevant for a certain application. And then what can be done, for example, is if I would now be a farmer and I would be, say, in a particular area of Krakow, say, let's have a look, this area of agriculture. And I'm in this area where there are some red spots. Yeah, so I would like to see how has that actually developed over the last summer. Was it as critical as as now in winter, which might be, winter time is not so relevant, of course. We can create, with these type of tools, we can create a direct time-lapse animation. So just to show you how that works, I can create a time-lapse where I say from date, let's take the beginning of the summer, let's take the 1st of May, and the end of the summer, maybe the 1st of October. And then I can say, let's take one picture per week for that area. Search. Now it's searching the whole database for this period of the Sentinel-2 sensor. And here I can also, of course, say, let's not maybe search on 100% cloud, because you can see here some of the images that turn very blue, of course, is disturbed by clouds, or here you see the same. So I can also set this filter to maybe only look for the pictures that are very visible. Yeah, and then from this area, I can simply play this small video, and then you see how that moisture has developed over the summer period. And then you see actually that, yes, there are areas that have more problems than others. And that could mean for a particular farmer, okay, I'm doing everything right, or maybe I have to do it better because my neighbors in the same environment have a much better situation. And of course, these results can also be downloaded just like any other detailed picture that you might want to have for your reference. I will not download it now, but you see it directly downloads to my local disk if needed. That's one example. That's what Sentinel-2 can do. You also saw that we have Sentinel-1, the radar satellite that works day and night. And I will show you one example of this, how that works. So this is a service of the German government, of the federal government, that uses Sentinel-1 data to look at the whole of Germany where there is ground movement. The benefit of satellite data is that by taking pictures every 2-3 days of the same position, you can really detect movements within millimeters. And that is, of course, very interesting, not only for infrastructure like buildings and roads. Yeah, you can really see movements of building and roads, but also we know, especially like in the Ruhrgebiet area here of Germany, there have been a lot of problems due to the old mines that are not being used anymore, and we have a lot of problems with the ground moving, and that of course impacting the buildings and the road infrastructures in those areas. So here of this service, you can see also that if we zoom in a bit, that this gives a very detailed picture of where there are issues. And this is an issue where there are a lot of, let's say, how do you call that? Braunkohlegewinnung. It's coal mining, exactly. So there, of course, there's a lot of change, you can imagine, because the coal is carried away. So you see a lot of difference changing there. So that's maybe not so relevant. But you see in other areas, you see also spots with red and yellow. Red meaning the highest movement of more than 1 centimeter per year. So that's quite significant. Just imagine your house would be moving more than 1 centimeter per year. And then it allows me to just zoom in and see where is that happening and why is it maybe happening. So you see that sometimes these effects are occurring really at a roadside in a very particular area. So for a government, a perfect indication to say, hey, here is really a potential problem because the road might break, might get a lot of problems during rains, and let's have a look at that. And that is maybe where also then the problem needs to be analyzed more deeply, and where probably with other sensors and IoT, one could help to then observe such an area for a longer period of time and 24/7, rather than the satellite waiting for the next satellite image. So that is an example of how radar data is being used. Maybe two more examples. We have time. And then we will go to questions. Another area, what you might have seen from the news, is that we have a lot of issues with the drought in Europe. The changing climate means that we will get less and less rain in certain areas, more rain in other areas. That is not expected. One of the areas that is under very intense observation is the Danube region, because there's a lot of agriculture in that region, and of course very important for the rest of Europe that this works well. What has been done here is that all the satellite data that we collect over the years has been put into a so-called data cube, so that you can analyze this data of the Danube region even faster than I've shown you in the picture, not going image by image and searching for the images, but directly asking for a certain criteria in a certain region, and it will show you the last 8 years of data and analyze it. So that is a mathematical model that allows us to search through petabytes of data within seconds. And these data cubes are starting to be applied to a whole range of applications, not just this type of drought monitoring. And a last example, again with water management, which might also be some of the areas relevant to IoT, is water management. You know that worldwide we have limited resources of fresh water. Very important to monitor that, especially in certain countries. Like here, this is an example of a lake in Turkey, which is fed by a river. And it's very important to know at any point of the year what the level of the lake is, so to say, what is the capacity of fresh water that we still have for the coming period. And with the satellite data, what we are able to analyze is really over the years how that water level develops, and to see if there are any extreme situations, like here, of course, on the summer of 2020. And then, of course, again, for the government to take action. So this is really very easy to understand. Of course, much different from a satellite picture, but it shows exactly what a particular user would need to take action on a certain situation. And then, of course, also to maybe analyze how it has developed by simply scrolling through the time and going from one picture to the next picture. And then to say, we have to analyze this more in detail because we see a trend, and that could mean the next step being, let's go to that area and let's monitor that 24/7 on the ground, and collect more specific data to understand what is happening and why it's happening. Right, thank you for listening, taking your time. I hope it was interesting, and of course would love to answer any questions.
Thank you so much, Jurry. I hope you can hear me fine. My internet is also not acting very at the end was very good for, I think, all of us to understand how you can make use of this data. And I do have a question actually from my side. So I am coming from the IoT domain, and like everything you had seen would be so useful, really incredibly useful for a lot of companies in IoT area. But my question would be here: is it like how is the get started process? So is it really easy for an IoT startup to gather this information using the Copernicus ecosystem, or is there like a big learning curve involved in that getting started process, or is it like as straightforward as you had shown today, that a new company without not so many prior experience in that area can gather all these meaningful information?
Yes, good point. Of course, one needs to think of the business problem first, but that is where we start. Yeah. So if you have a certain business idea or business problem, contact us. Yeah. We help to say, analyze if satellite data can help, if Earth observation data can help analyzing that problem, because there are certain things that are not possible, of course, with satellite data. We do not have a 24/7 monitoring of every part of the Earth. That's impossible with nowadays technologies. So if you have a certain idea, come to us, and that's where our support starts, to help you get easy into this domain of what is possible and what is maybe not possible, where to focus at. And then, of course, we can also sign NDAs to keep that confidential between us, because we want to make you successful. Yeah, it is our task is to provide the data, not to develop applications on top of it. So there is, I think, a natural win-win situation then. If the data is being used more, we benefit, and you benefit with a certain application that you can monetize. And once we then get into the detail, I think it will be very easy to understand. That's what the tools do. Yeah, they make the data very easy to understand and make also the data very accessible. So I think programming then the solution at the end with the tools that we have is not a big step for any programmer.
Okay, understood. Thank you so much. And there's another question on the chat. I also put it on the screen for you to hopefully see it better. So can you come back to the topic of sentinels, and what is the resolution of the sentinels? Maybe, and the units of centimeter over pixels, if possible.
Yes, the resolution. That's a good question. Obviously, there are different resolutions of the satellites. The Sentinel-2 satellite providing those vision of 10 meters by 10 meters. Yeah, so you can see a house, you can see a car on the ground, but you cannot read the license plate. Yeah, so that shows you a bit the day-to-day resolution that we can achieve with that. With the radar satellite, we have a completely different resolution that is in the centimeter area, because of the behavior of the radar and the reflection of the radar on objects. And that allows us to analyze really changes in centimeter area. So by combining radar and visible satellite images, which is also possible because of the geometry, you can put them on top of each other. Some issues, of course, can then be analyzed in centimeter area, like for a building. If that building would have, say, infrastructure problems because of ground movement, we can even show which side of the building that happens. Or a bridge in a rail track, we can show where is it in the rail track exactly where it is moving. I hope that answers.
Wow, that's very high resolution. Yeah, I hope this answers that question. So thank you so much for your question, Ran. And yeah, then we can wrap it up at the moment. Jurry, thank you so much for your presentation. I hope it was very helpful. And again, it will, if you just missed this session, you can always find it in hubraum's website and the LinkedIn page. And if you have any questions, you can always contact us and we will find you the right answers. Thanks a lot, Jurry, for joining today.
Welcome. Thank you too for listening. Bye-bye.
Have a nice day, everyone. See you in the next session on Friday. Bye.